Hello everyone, and welcome to Algebra 2. This is section 6.7, Modeling with Exponential and Logarithmic Functions. So we're actually going to take a step back and look at all the functions that we've learned this year. I think you're going to be pretty pleased with yourself. We've learned linear, quadratic, cubic, exponential, logarithmic. So hopefully you have a good sense of all the different shapes. See if you can go ahead and match which graph goes with each of the functions. So of course, I am going to do it for you. So linear has the word line in it. So of course, both of these are lines. Positive slope is going to be this one. So this is number 1. And then negative slope will be this one. So this is number 2. A quadratic function makes a parabola. So this is number 3. A cubic function has this general shape. So this is number 4. This has been shifted up, but that's okay. We're just trying to match the general shape. Let's see, exponential. This is what we look at when we see exponential growth specifically. It has an asymptote here. So this is number 5. And this is going to be logarithmic, which is the inverse of the exponential function. Not that you need to draw that on there, just as a reminder. So this is number 6. But what if you can only see the first quadrant? Suddenly this problem becomes a lot harder. You don't actually know if this one's quadratic. This one might be quadratic. Even this one might be quadratic. Or maybe all of them are exponential functions, where they start off slow and then slowly rise. It becomes hard to tell. In general, what I really want you guys to know is that squareds don't grow as fast as cubes, which don't grow as fast as exponential functions. These are going to be, in general, the steepest graphs you get, because just think about 10. If you have 10 squared versus 10 cubed, 10 cubed is definitely bigger, but something to the 10, that's really big. So the bigger you get, the steeper the graph becomes. However, what I want you to also know is that you can't just plug in numbers that are, like your typical 0, 1, 2, because sometimes in the beginning, it's hard to tell. So let's just do a quick example of some possibilities. X is equal to 0, 1, 2, but then going all the way up to, like I said, 10. So if you had something like 5x squared, and we'll just do plain old x cubed, but 1/8 2 to the x. So when you plug in 0, you get 0, 0, anything to the 0 power is 1, so 1/8. When you plug in a 1, this one looks like, oh, well, this one's growing faster. Yeah, maybe right here. In fact, 2 to the 1 times 1/8 is only 1/4. So this one just got a little tiny bit bigger. And then when you put in a 2, 2 squared is 4, 4 times 5 is 20. Like, yeah, this one's taken off. That 5 is really making it grow fast. And then 2 cubed is 8, definitely not as big. And even here, 2 squared is 4, 4 times an 8 is still only a half. But in the end, while this one might be growing faster in the beginning, in the end, 100 times 5 is 500. But once you just get to 10, this guy has really shot up. This one's already at 1,000. And I don't even know what this one is. 1/8 times 2 to the 10th. It's huge, needless to say. So in the end, exponentials are always going to be the steepest and grow the fastest, even if you can't see it just by plugging in a few numbers. So we're actually going to do some exponential functions, but just to show you that it relates to something you've already learned, we're going to start by writing the equation of a line. Hopefully, as soon as you see these words, you should be thinking y is equal to m times x minus x1 plus y1. If you're using that equation, writing the equation of a line is super easy. You just have to find the slope, which is y2, minus y1 over x2 minus x1. So this is 48 over 2 is 24. By the way, it doesn't actually matter which one is x2 and x1 or y2 and y1. If I had done 6 minus 54 instead, and then 1 minus 3, I just would have gotten negative 48 over negative 2, which is still 24. So it doesn't matter the order as long as you are consistent in the numerator and the denominator. I can pick either point, but I might as well pick the easier one. So x minus 1 and then plus 6. And this is considered a perfectly valid equation. If for some reason you'd like to multiply it out, you're welcome to, but it doesn't really gain you anything except finding the y-intercept, which you could have found by plugging in 0 for x. So this would be 24x minus 18. So the same thing is going to happen here. As soon as it says write an exponential function, you need to be thinking y is equal to ab to the x. Now in this case, a is not slope. This is the biggest mistake that people make. The reason we can do slope for a line is because a line stays at the same slope the entire time. So it doesn't matter which 2 points you pick. For an exponential function, the slope is constantly changing. The slope is really shallow here, and then it gets bigger, and it becomes really steep. So depending on which 2 points you pick, you're going to think it has a different slope. So this a is definitely not slope. Instead, you're going to use the equation twice and solve the system. So first one, y is equal to ab to the x is going to become, I'm going to put in this 1, 6. 6 is equal to ab to the 1. And then the second one, y is equal to ab to the x. I use the exact same one again. Now I'm going to use the point 354. 54 is equal to ab to the 3. So I have a system of equations now. I can't use combination, but I can use substitution. So I'm going to say that a is equal to 6 over b. And I'm going to plug that into here. So 54 is equal to, I'm going to replace a with 6 over b, and then times b cubed. That gives me 54 is equal to, remember, whenever you're multiplying a fraction by a whole, you can make that over 1 so that you can go straight across the numerator and straight across the denominator. That gives me 54 is equal to 6b squared. Divide by 6 is 9. And I get b is equal to, now technically it's plus or minus 3, but you're going to let your b be greater than 0. When b is equal to 3, a must be equal to 2. So I'm going to take this, I'm going to substitute it right in there, and that gives me a is equal to 2. Sorry about this, I definitely ran out of some room here. So my final answer is going to be y is equal to a times b to the x. And that's how you write an exponential function. Using the exact same 2 points, notice how different my 2 answers come out. It makes a difference what kind of function it is. All right, you can go ahead and practice that on your own. The answer to the first one is y is equal to 1/2 4 to the x. This is another way to write it in parentheses. Y is equal to 2 times 3 to the x if you don't want to use the dot. So you can go ahead and try that one on your own, but of course I will do it for you. So same thing. I'm going to write my equation twice. I'm going to fill it in twice. First with 1, 2. 2 is equal to ab to the 1. And then with 3, 32. 32 is equal to ab to the 3rd. I have a system of equations now, and I'm going to use substitution. I personally am going to choose to let A be equal to 2 over B. It would work to substitute in B is equal to 2 over A. So I'm going to put that in there, and that gives me 32 is equal to 2 over B times B cubed. Again, when you're multiplying a whole by a fraction, it's often easier to change it to a fraction times a fraction. And you could do it the way I did it last time, actually multiplying across, or you could cancel one of these with one of these, and that just gives you straight up 2b squared. Divide both sides by 2 gives me 16, and therefore b is equal to, technically plus or minus 4, but we're going to use b is greater than 0. Now I plug that back into here. 2 over b is equal to a, so a is equal to 1/2. And now I've figured out this equation. It's y is equal to 1/2 b to the x. All right, so if you watch that one, you definitely should try at least one of them on your own. This next one is y is equal to 64 times 1/2 to the x. So go ahead and try that one on your own. Of course, I'm going to do it for you. Y is equal to ab to the x. I'm going to write that twice. And then I'm going to fill it in first with 216. 16 is equal to ab squared. And I'm going to fill in the 5, 2. 2 is equal to ab to the 5th. So personally, you have noticed I keep solving for a. So 16 over b squared is equal to a. I think that that's a little bit easier. And then I'm going to put that into this equation. 2 is equal to, and I'm going to fill the a in using substitution with 16 over b squared. And that gives me 2 is equal to 16b to the 3rd. I divide both sides by 16 and get 1/8 is equal to b to the 3rd. I take the cube root of both sides, step we didn't have to do last time, and I get b is equal to 1/2. Now, people's biggest trouble is actually going to be in this next step, 16 over 1/2 squared. Not that your calculator won't do it for you, but again, let's talk about how to do that. I would change it to 16 over 1/4, and then if you change that to 16 over 1 over 1 over 4, then you can flip the bottom one and multiply. So some of you might do it as keep, change to multiplication, and flip. But as long as the bottom one is the one that gets flipped, that's really what you need. And so a is equal to 64. My final equation is y is equal to 64 times b to the x. You might remember classifying data from some other lessons that we've done. We're going to use finite differences to determine the type of function that represents this data here. So notice that finite differences only work for polynomial functions. Let's see if you remember how we did this. As long as x is increasing at a constant rate, so in this case, you're adding 2 each time. Doesn't matter if you're adding 1 or adding 2. Then you can look to see what y is doing. So y is subtracting 2, but then y is adding 2, then y is adding 6, and then y is adding 10, then y is adding 14, and finally to get from here to here you have to add 18. So this is not linear. If these had all matched, it would have been linear. So I do a second round. From -2 to get to +2, I have to add 4. And I'm sure you can already see that for all of them, I'm going to add 4. And whenever your data does that, that's how you know that something is quadratic. Hopefully that's coming back to you. Like I said, that's a review from a previous chapter. So see if you can find the pattern that will let you know what this is. So you should work on it on your own, but of course I am going to do it for you. Again, x is going up in a steady rate. But what is y doing? To get from, might be easier to think of this as 1/2. How do you get from 1/2 to 1? You could add a half, but this is definitely not add a half. This is adding 1. And then this is adding 2. Ooh, and then this is adding 4. This is adding 8. You definitely see the pattern, right? But then when you go to do it again, it's adding a half, and then adding 1, adding 2. Can you see this is never going to improve? Okay, this is not, now we know it is not a polynomial function. Polynomial functions would change over time. So what's another way for numbers to increase? Either they are being added or they're being multiplied. So again, I'm going to change this to a 1/2. To get from 1/2 to 1, I can multiply by 2. And from 1 to 2, I can multiply by 2. From 2 to 4, I can multiply by 2. From 4 to 8, 8 to 16, and 16 to 32 is all multiplied by 2. This is what tells you that something is going to be exponential. And think about what exponentials look like. Y is equal to something to the x. In this case, 2 to the x. You've multiplied by 2 one time, 2 times, 3 times. What's the notation for multiplying 2 by 2 by 2 by 2 by 2? It's 2 to the 4th. Can you see the relationship between how you're multiplying each time and how this is some kind of an exponential equation? So even though I have this much, just like we did a minute ago, I still know that there could be an a here. I know that it's 2 to the x, but I still have to find a. So how do I do that? I can take any one of these points and I can plug it in. So I know that at 4, when x is 1, then a must be equal to 2. So this is y is equal to 2 times 2 to the x. Or you can put it in parentheses if that helps. And of course, you could check another point. If I plug in x is equal to 4, I should get 32. And sure enough, if x is equal to 4, 2 to the 4th is 16 times 2 is 32. So I did that equation correctly. So let's do number 3 now. Actually try and figure out what this function is that's represented by this table. So we're in the exponential chapter, so you can probably start with trying to multiply by something each time instead of adding. But multiplying isn't going to work here. In fact, these numbers are going down. So if they're going down each time, what's the mechanism for making a number go down? Not necessarily multiplying, but dividing. But dividing is not exponential. So you do have to continue to use multiplication, but you can make it like division by doing times a third. Multiplying by a third is the same as dividing by 3. If you had 21 cookies and you multiplied them by a third, that would give you 7 cookies. But if you had 21 cookies and divided it by 3, that would still give you 7. So multiplying by a third and dividing by 3 give you the exact same answer. And as you can see, that works for all of them. Divide by 3, divide by 3, divide by 3. So each time you're multiplying by a third. But when you're writing exponential, you can't use divided by. You have to use multiplying. So now I know that this is y is equal to something times 1/3 to the x. How do I find that something? I pick any point I want to. So let's just pick the easiest one. Let's pick 0. So when x is equal to 0, y is 27. 27 is equal to a times 1/3 to the 0. Why did I pick that one? Anything to the 0 power is 1. So a is 27. So my final equation is y is equal to 27 1/3 times 1/3 to the x. Number 4. So I'm going to look at this, and I'm going to try and figure out how to get from here to here. Do I add each time, subtract each time, multiply each time, or divide? Well, you got to start with the easiest one. It's definitely going down, so it's either divide or subtract. And since it's going down by 3 each time, then I can just go ahead and use that. I don't need to do multiplication or division. So remember what that means. If it takes 2 rows for it to change the same each time, then it's quadratic. If you multiply by something each time, then it's exponential. But if you add or subtract and on the very first time there's already consistency, then it's linear. So I can say that y is equal to m times x minus x1 plus y1, where this is just any point. So I can pick any of these points. Of course, I'm going to pick 0, 15. That's the easiest one. And then what's the slope? Now be careful. The slope is not -3. Really easy mistake to make. But you always have to look at how much x is changing each time. So since x is going from 0 to 10, while y goes from moves -3, the slope is -3 over 10. And if that didn't make sense just doing it in your head, then you could actually just take 2 points. So if I took 2 points, then it would be y2 minus y1 over x2 minus x1, -3 over 10. So just be careful of that. It's not just this number. It depends on how much x is moving each time. So my final answer is y is equal to -3/10 x, since that's a 0 plus 15. I can simplify it a little bit. Okay, so last one of these. So sometimes none of this works. You look at this and you say, all right, that's -8, but then it's +8, and then what is that? +14, +50. I'm not seeing a pattern here. To get from here to here would be +16, but to this would only be +6. To get from there to there, this is not going to have a quadratic pattern. So then I think to myself, well, maybe it's exponential. What could I multiply by each time? Nothing easy, right? So this is where you're going to want to use the regression feature on your calculator. So the first step is to go to Stat, and let's edit our lists. I still have lists in there. You probably do too. So go up to the L2 and hit Clear, Enter, and then go up and over to L1 and hit Clear, Enter. And now you can enter your list in there. So I have -2. Make sure you use the negative and not the subtract key. Enter, 0, enter, 2, enter, 4, enter, 6, enter, 8, enter. Then use the arrow key to go over. And I'm going to write in 13, and then 5, and then 13 again, and then 27 again, 77, and 133. Now when I make my window, I'm going to want to see the data from -2 to 8, and the y values from 13 to 133. So I go to Window, and I want to see this from -2, but I'm going to just say -5 to make sure I can see it, up to 10. And that y value was never lower than 5, but it's just easier to start at 0. But I need to get all the way up to 133, so I'm going to say 150. Now remember, this graph is only for lines. You need to hit Stat Plot and turn those on. So I hit Enter, and then Enter again to turn it on. And now when you hit Graph, you should be able to see it. Although I'm going to see if I have a line in there. I don't. Otherwise, I would also be seeing the line. All right, so there you go. Ooh. So is it exponential? I can rule that out. There's no way that this is exponential. It's not linear because it has this right here. So it's either quadratic or quartic, some kind of fourth power function. So I go back to Stat, And now I want to calculate my regression. So I'm going to go down to quadratic regression first. It's going to use my list 1 and my list 2. So that's great. I just keep hitting enter until it calculates it for me. Now notice I got a correlation factor of 0.995. That's really good. That means that data fits with this equation 99.5%, which is great. But I do want to also just check, I do want to check Quartic. So back to stat, back to calculate. Now I'm going to do a Quartic regression and see if it comes out better. And then if it doesn't, then I'll go back to cubic or back to quadratic. Enter. Ooh, 0.997, just a tiny bit better. So I've written the answer here using the given A, B, C, D, and E that your calculator found. Make sure you put that into an equation. All right, last one. So a store sells trampolines. The table shows the number Y of trampolines sold during the X year that the store has been open. Write a function that models the data. So I'm always going to try adding first because it's easy. So this is add 4, add 9, add 11. Okay, so definitely not linear because this is add 5, but then this is add 2. So it's not linear, and now I realize it's not even quadratic. Let's see, this is going to be add 14. This is going to be add 17, add 29. So this is not looking good. I don't even think I'm going to do it one more time. Ooh, this is minus 3. Minus 3 plus 1 plus 0. Okay. So I'm going to give that up. That's definitely not working. So now I'm going to try multiplying. Now this is not easy to multiply, but I want to show you an easy way to do it. 12 times something, let's just say W, is equal to 16. How do you figure out what that number is? You do the algebra. W is equal to 4/3. That's what they multiplied by, 4/3. So now let's just see if you multiply again by 4/3 to get from 16 to 25. And it's definitely not. 64 over 3 is 21 1/3. So it's closer, but it doesn't actually work. So there's no consistent multiplication. So this is where you're going to want to use your calculator again. So if you've already got the hang of this, you're welcome to do it on your own. But if you need me to get you started again, then remember the first button that you push is Stat, and then Edit so that you can put your lists in. I already did it, list 1 and list 2. And then make sure your stat plot is on. Second y is equal to will take you to stat plot, and mine is on. Make sure your window fits the data. So I made mine from 0 to 10. I really only need to go up to 7, but I just always give it a little bit of wiggle room. And my y data needs to go up to 96, so I just made it an even 100. Hit graph, and then you can look at the data. So it's hard to tell. This could be parabolic, which is quadratic, or it could be exponential. It could even be quartic. So to figure any of those out, you're going to go to Stat, and then Calculate, and then you're going to choose the regression. Each one will give you a correlation factor. So if you choose number 5, it'll give you the parabola, the quadratic regression. It could be a cubic regression, a quartic regression, which is x to the 4th. Okay, I'm not even going to try the linear. I know it's not a linear regression. It's definitely not a line. And when you have to go down one more to 0 to see the exponential regression. So that's going to give it to you just like we've been doing, where, see, it gives you this format, a, b to the x. So this would be your a, this would be your b. And so my r squared, my correlation factor, came out really high, 0.997. But you can go ahead and do all of them and figure out which one you think is the best fit, and then put that answer on your paper so I can check your notes. All right, that is it for section 6.7. Have a great day.